So atoms are the smallest indivisible particles of an element, and yet atoms themselves have parts. And it's kind of interesting how we came to understand what we do understand now about atoms. J.J. Thomson, back in the early 1900s, discovered the particle that is called the electron. The electron has a negative charge. It is smaller and much lighter than the atom. In order for it to be part of the atom, it obviously would have to be smaller than the atom, or it couldn't be within the atom. But it's a lot smaller than the atom. And it's also very light, and they found that electrons were common in many different substances, that they all had atoms in them. So Thomson proposed that atoms must have some positive charge that balances these negative charges, because they knew that atoms were neutrally charged. They didn't have a positive or a negative charge. So if it's got some negative particle in it, there must be some positive particle or something in there to balance out the charge. And so he came up with what's known as the plum pudding model of the atom. And, you know, being Americans, we don't know what plum pudding is. You think of, vanilla pudding with plums in it. It's really more like a blueberry muffin. So it's like a cake-like thing with blueberry muffin, except they use plums. I don't know. Maybe we should bake it and bring it in and try it. Anyway, the plum pudding model is more like a blueberry muffin where the electrons are like blueberries and the atom is the muffin. And so the blueberries are just kind of randomly distributed throughout the atom. And that was his hypothesis, his model of the atom. Well, people then took this idea and they're like, well, let's see if this is true. Let's test this hypothesis. And so Rutherford, who I believe was a student of Thomson's, devised this experiment to test it. He was not setting out to disprove this theory. He was actually trying to prove that it was correct. But the way he did this is he took this source here of particles and shot them at a very thin piece of gold foil. And then they had this screen around the outside that was would give a little tiny flash of light when these particles would hit it. And that's how they could tell what happened to the particles. What they found was that most of the particles went straight through. And that was not unexpected. Because if it's like a blueberry muffin and you're shooting particles through it, what is it hitting in there? So it went through. Some of them were deflected at right angles, and some of them bounced almost straight back. And that was very, very surprising. So this is what they're looking at here. If the plum pudding model were correct, then those particles should just go straight through and not really be deflected at all, because those electrons were very, very tiny. They were smaller than these particles that they're shooting at them. And so you don't expect something smaller to make something bigger bounce off. So they expected the particles to go straight through. They did not expect them to come back. But some of them came back. Rutherford said that this was as surprising as if you shot a cannonball at a piece of tissue paper and it bounced off the tissue paper and hit you. That's how shocking this result was. They were like, what on earth? How is this happening? Those are supposed to go straight through. They're bouncing back? How can a cannonball bounce off a piece of paper, right? It's just completely unexpected. So this led to a modification of the atomic theory. And so they determined that there must be something inside that was very massive, and that turns out to be the nucleus. The nucleus is very small and very dense, and it's in the center. When those particles hit the nucleus, they would bounce back. If they came close to the nucleus, they would be deflected at large angles. But most of the atom is empty space, and through that empty space where those little tiny electrons are, that those particles could just go straight through. Okay? But there's this thing in the middle, this core, that's super dense, and so when the particles hit that or came near to it, they bounced back, but all the rest of the particles went through. So Rutherford's nuclear theory of the atom included the nucleus. So his theory states that most of the atom's mass and all of its positive charge is located in this small core called the nucleus. Most of the volume of the atom is empty space, and in that empty space you've got these little tiny negatively charged electrons. And they're going around in there, and he didn't really express any theories on what they were doing there. That turns out to be very, very complicated. The number of negatively charged electrons is equal to the positively charged particles that are in the nucleus. They have opposite charges, and for the overall atom to be neutral, you have to have equal numbers of them. Those positive charges are called protons. Protons are positive. Both words start with P. So in this image, it's been enlarged so that we can see what's going on here. But the size of these electrons is crazy small. They're 2,000 times smaller than the particles in the nucleus. And this atom, just to give you an idea of the scale of the atom, if the nucleus was the size of a green pea, and you put that on the 50-yard line of a football field, the nearest atom would be at the goal line. And what's in between there? A few electrons, and mostly nothing.
What's the vacuum?
A vacuum is nothing, yeah. It's empty space. So matter is mostly empty space. Let's just look real quick here at electrical charge. Protons have a positive charge, electrons have a negative charge. This is a fundamental property of them. They cannot lose that charge. They always have that. They are oppositely charged, and their charges are equal in magnitude. Opposite charges attract each other. We're talking about electrical charges, but they behave in a way very similar to magnets. The north pole and the south pole of a magnet attract each other. Opposite charges, positive and negative, attract each other. If you get two south poles of a magnet, you can try to push them together, but they're going to force themselves apart. Two negative charges or two positive charges will repel each other. And so this concept of opposites attracting and positives and negatives balancing out to zero is a really important concept that we use when we talk about ions and just atoms in general.